Good morning, students. Our subject is Design of Concrete Structure 1. Our today's topic is doubly reinforced rectangular section by limit state method, part 1. In a last part 1, part 2, part 3, part 4, and part 5, we solved singly reinforced rectangular section by limit state method. We design beam by the singly reinforced section. In today's lecture, we design beam by doubly reinforced section. What is doubly reinforced section? We provided a steel in compression and tension zone also. It is called as a doubly reinforced section. Stress strain diagram and stress block diagram for doubly reinforced section. We have to study here about doubly reinforced section and how to design doubly reinforced section. Okay, so tension reinforcement is designed for a stress of 0.87 fy, but for compression reinforcement a lower stresses must be used because steel bar may buckle between shear stirrup under a compressive stresses. Here is a stress strain diagram for a doubly reinforced section. We provided in steel in a tension zone and compression zone also. It is called as a doubly reinforced section. Here we provided AST and here we provided ASC. In tension zone we provided AST. Compression zone still it is called as a ASC. C means what? Here cover we provided. It is called as a C. D means effective depth of. It is a effective depth of beam. Capital D is equals to what? Overall depth of beam. Okay, and it is a width. Okay, it is a cross section of beam. Now strain diagram. Here a strain diagram. This distance is XU. Up to this distance D dash. It is a epsilon SU. Epsilon CU means steel, strain of steel, strain of concrete. Okay, it is a triangle of strain diagram. So 0.002, and here epsilon SU is 0.002 plus 0.87 into Fy divided by ES. It is a strain diagram and it is a stress block diagram. Here is a stress block diagram. Up to this distance is D dash. From 0.002 to below it is a Z. Z is it is called as a lever arm, and lever arm value is D minus 0.42 XU. Okay, up to above, up to this bar the distance CU1 is a compression in concrete. This distance is a Z dash. What is Z dash? Z dash is equals to D minus D dash. Okay, and here is TU. Okay, this is a strain block diagram. Here we already seen B is a width, D is a effective depth, D dash is effective depth of compressive reinforcement, AST is area of tensile reinforcement, ASC is area of compression reinforcement. Okay, first how to solve, how to calculate TU, how to calculate CU, how to calculate CU1. So here we study some formulas to calculate TU, CU and CU1. Okay, what is TU? Tensile force carried by tensile reinforcement, that is TU. Here tensile forces, so TU is tensile forces. Formula is 0.87 Fy into AST. If you have to calculate TU, then use this formula 0.87 Fy into AST. Second, calculation of CU, compression force carried by concrete. Compression force is a CU. CU formula is 0.36 FCK into XU into B. It is called as a CU, compressive force carried by a concrete. Third, CU1. What is CU1? Compressive force carried by steel. So CU1 is equals to FSC minus FCC into ASC. What is FSC? FCC, FSC, what is this? So where FCC is compressive stresses in concrete at a level of compressed steel. So compressive stresses in concrete up to a level of compressive steel, it is called as a FCC. How to calculate FCC? FCC is equals to 0.45 FCK. Okay, so 0.45, if M20 is given, then multiplied by 20, so 0.45 into 20, it is a FCC. Okay, you all know what is FCK, is a M20 grade of concrete. Okay, mixed proportion of the concrete. If D dash is greater than 0.43 XU, if it is not great, D dash is not greater than if 0.43 is not greater than D dash, then consider FCC is equals to 0 or it is neglected. Okay, so if D dash is smaller than 0.43 XU, then put 0.45 into FCK. If D dash is greater than 0.43 XU, then consider 0 neglected. Okay, what is FSC? FSC is compressive stresses in steel. How to calculate compressive stresses in steel? FSC is equals to 0.87 into Fy. Fy is a grade of steel. 3 grade of steel. First is Fe250, Fe415 and Fe500. If grade of steel is mild steel, Fe250, then only use this formula 0.87 into 250. Okay, if grade is different 415 and 500, then use another table. Okay, so the table here is stresses FSC compressive reinforcement for D dash, the ratio of D dash to D. This ratio, if grade 415 and 500, if the grade is 250, then use this formula 0.87 into 250. But if grade is 415 and 500, then use this table, grade of steel 415 and 500. So ratio D dash divided by D, 0.005, 0.1, 0.15, 0.2 means D dash divided by D. If D dash is 40 and D is 400, then consider what is ratio? Then the ratio is 0.1. Then if grade is 415, then use 352. If grade is 500, then use 412, like this. Okay, so for 415, the value is given here 355, 352, 342, 329. Ratio is given here. And if 500 grade is given, for 005 D dash by D ratio, use 422. If ratio is 0.1, then use 412. If ratio is 0.15, then use 395. If ratio is 0.2, then use 370. Okay, use this table is very important, because without this table you can't design doubly reinforced beam by using limit state method. Okay, so this table is important when a grade is given 415 and 500. Okay, now silent point on a design stress strain curve for cold work bar. If cold work bar is given and steel level is given, then use this table. Okay, for Fe415 and Fe500. Next level step is here to calculate lever arm between TU and CU. Okay, if we have to calculate Z, then use this formula. Z is equals to D minus 0.42 XU. If we have to calculate Z dash is the lever arm between T and CU1. If we have to calculate lever arm between TU and Z1, then this formula use. Z dash is equals to D minus T dash. What is D? Effective depth of beam. It is a D, and D dash is cover of compression zone up to compression bar. It is a T dash. Okay, and to calculate depth of neutral axis, equilibrium requirement in a horizontal direction givens. So to calculate TU, the formula is CU plus CU1. It is called as a TU. But you know what is CU? We already seen here. What is CU, what is TU, and what is CU1? So CU is 0.36 FCK XU into B. What is TU? 0.87 FY into AST. What is CU1? FSC minus FCC into ASC. Okay. So put this value here. What is CU1? CU is 0.36 FCK XU into B. It is a CU. FSC minus FCC into ASC. It is a CU1. And TU is equals to 0.87 FY into AST. So it is TU. Okay. So here you have to calculate XU. Here you have to calculate XU, depth of neutral axis. So 0 is equals to 0.87 FY into AST. Here plus value, so go to here, that is minus 0.87 FY AST minus FSC minus FCC bracket close into ASC. Okay, divided this to this multiplying value 0.36 FCK into B. So divide this. Okay, if XU value you have to calculate, then use directly this formula. Okay, XU. How this formula created, we already study here. Okay, so you can directly, if doubly reinforced section you have to design, then directly use this. Okay. Next, if limiting depth, you have to calculate limiting depth. How to calculate limiting depth? Grade of steel is F250, Fe415 and Fe500. Then XU max. Limiting depth means XU max. If you have to calculate, then for Fe250 the value of XU max is 0.53 D. If you have to calculate Fe415, then use 0.48 D. If grade is Fe500, then use 0.46 D. Okay. Now we are going to start here, solve some numerical examples to calculate moment resistance MU. So study here type 1, calculation of moment of resistance. MU you have to calculate here. So example number 1, we start here. Calculate the ultimate moment of resistance. Means what you have to calculate here? MU. We have to find what is MU of RCC beam. 300 mm wide. Means width is given here. B is 300 mm. Okay. And 380 mm deep overall. Overall depth means here capital D is given. Capital D is equals to 380. Okay. The tensile steel consists of 6 number of 20 mm diameter. Means in a tension side. AST. Tension side means area of steel in tension zone. 6 mm diameter. 6 mm diameter. 20 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 mm dia 6 bars is given and 20 diameter. So how to calculate area? Use formula pi by 4 into d square. And how many numbers? Multiply by 6 numbers. You got easily area of steel in tension side. Okay. And compression steel consists of two numbers of 20 diameter. In compression side, two bars are provided who's having 20 diameter. So 20 diameter of two bars. How to calculate ASC? ASC is equals to 2 into pi by 4 into d square. Diameter is 20. So assume here grade of concrete is 20 and grade of steel is mild steel. Mild steel is Fe 250. So and effective cover to both steel is 40 means both steel cover means in a tension side and in a compression side, both side the cover is same 40 Okay. Now given data is here. Width is 300 grade of concrete is 20, grade of steel is mild steel Fe 250. AST in a steel tension side 6 bar of 20 diameter is provided. How to calculate AST? Pi by 4 into d square and the number of bar is 6. So 6 into pi by 4 into d square. Diameter of bar is 20. So AST is 1884.95 square. So it is a AST, area of steel in tension zone. Now overall depth is given 380. Cover in tension side and cover in compression side is 40 Okay. How to calculate small d or effective depth? How to calculate effective depth? Effective depth is equals to overall depth minus cover. Overall depth is 380 minus cover is 40. So a small d is 340 Okay. So effective depth is 340 ASC is 2 bar of 20 So 2 bar is, how to calculate area? Pi by 4 into d square into number of bars. Number of bars is 2. Pi by 4 into diameter is 20 square. So ASC is 628.81 square. Now calculate depth, actual depth of neutral axis XU. So first step here, we have to calculate actual depth of neutral axis XU. We already studied here formula. What is formula to XU? Is 0.87 Fy into AST minus FSC minus FCC bracket close into ASC divided by 0.36 into FCK into B. So here we put all values. 0.87. Our Fy is mild steel. What is mild steel grade? Is 250. So Fy is 250. AST is 188.4.95. Here 6 bar of 20 diameter is given. So AST is 188.4.95 minus here FSC. How to calculate FSC? FSC is 0.87 into Fy for mild steel. Here mild steel is given. So FSC is 0.87 into Fy for 250 Our grade is mild steel, so you can easily use this formula. So formula is 0.87 into Fy. 0.87 into Fy is 250 minus what is FCC? FCC is 0.45 into grade of concrete. So grade of concrete is 20. So FCC is 0.45 into 20 into ASC. What is ASC? ASC we already calculated. 2 bars of 20 diameter is given. So we calculate area. Area is 628.31 divided by 0.36. FCK is 20 and B is 300. Okay. So XU is 129.15. By solving these numerical, you easily got XU. XU is equals to 129.15 Okay, now have to calculation of critical depth of neutral axis. Now second step is here, xu max. To calculate xu max is equals to 0.53d. Why we are taking 0.53d? Because the grade of steel is 250. So for 250, xu max value is 0.53d. Okay, one table is there. For Fe250, xu max value is different for 415 and 500. So for 250, xu max value is 0.53d. Our d we given here, our effective depth is 340. So 0.53 into our d is 340. So 340. xu max is 180.20 mm. Now compare xu and xu max. Our xu value is 129.15 and xu max is 180.20. Here we already calculated. In first step, xu is 129.15 and xu max is 180.20. So compare it. xu is smaller than xu max. xu max is greater. So section is under reinforced section. You all knows how to decide a section. If yes, xu is equals to xu max, then it is called as a balanced section. If xu is greater than xu max, then it is called as a over reinforced section. And if xu is smaller than xu max, then it is called as a under reinforced section. So our section is under reinforced section. Now fourth step, we have to calculate here moment resistance mu. To calculate moment resistance mu, the formula is Cu into Z plus Cu1 into Z dash. Cu is compression up to depth and Cu1 is our compression up to D dash. So how to calculate mu? Cu into Z plus Cu1 into Z dash. Z is lever arm and Z dash is D minus D dash. Okay, so what is Cu? Cu is 0.36 FCK into XU into B. We already got it. What is value of Cu, Cu1, and what is value of Z and Z dash. So Cu is 0.36 FCK XU into B. And Z is T minus 0.42 XU. It is a Z. Cu1 is FSC minus FCC into ASC. It is a Cu1. And Z dash is D minus D dash. Okay. So put value in this formula. 0.36, FCK is 20, XU is 129.15, B is 300, D is 340, minus 0.42, XU is 129.15 plus FSC is 217.5 and FCC is 9. ASC is 628.31 into D is 340 and D dash is 40. So mu is 119.20 kilonewton meter. 119.20 into 10 to the power 6 Newton mm. It is mu. So in today's lecture, we study here how to calculate mu and some step to design doubly reinforced section. Okay. Anyone having doubt in today's lecture, you can put your question in chat box. Okay, thank you.